This is the third part of the second lecture of week 11, where we'll consider another example, but in more general case where a, b, and c are some constants, and we have delta function on the right. So what is the special in this case? If we apply the Laplace transform to both sides of this equation, we obtain a square y of s plus bs y of s plus c y of s equals to 1, and so y of s is 1 over as squared plus bs plus c. And this, as you remember, the name of this function is transfer function. So there is no this function g, right? So in fact, if we now apply inverse Laplace transform to find the solution, this is inverse Laplace transform of the function h, and this is exactly the impulse response function. So to solve problem like this, to solve one, find the impulse response function h of t, which will be a solution of this equation. For example, let's solve, for example, the initial value problem like this. And in this case, the h of t is the inverse Laplace transform of 1 over s squared minus 1. This is the transfer function at a point t. So this is inverse Laplace transform of 1 over s minus 1 times s plus 1 at a point t. And this is inverse Laplace transform of the sum of 1 over s minus 1 minus 1 over s plus 1 at a point t. In fact, it should be a half right in front of, so it should be a half as well. So this is a half of inverse Laplace transform of 1 over s minus 1 is e to the t minus e to the minus t. So we get that the solution is a half e to the t minus e to the minus t.